Hi dear students, this is Vetri. Today we are going to see about introduction to queue. Already we have discussed two linear data structures. The first one is list and stack, and we have implemented the list and stack using both array as well as linked list. Today we are going to see about introduction to queue. See, under this topic we are going to discuss what are the pointers we have and what are the basic operations we have in queue and what about the limitations we have, okay, when you're trying to deal with these two operations. Okay, now let me explain what is queue. Queue is a linear data structure that follows first in first out principle. So what is first in first out? Which is the first element which comes into the list that is going to get served first. Okay, in example we can see in theaters, in the ticket counter, so who comes first, then who is going to get served first, right? So that's the principle we are going to follow in queue. Okay, now let us consider this example. Let me explain with pointers. Okay, so what about the pointer, front pointer? What is the duty of front pointer? So front pointer and rear pointer, for performing these two operation, when we trying to perform NQ, which is nothing but insertion. So when we are trying to insert a data into the queue, we are going to use rear pointer, and when we are trying to delete a data from the queue, we are going to use front pointer. So let me explain with an example. So first see, initially the value for front pointer will be -1 for an empty queue, okay, and for rear value also -1 for an empty queue. So if there is no data in the queue, means the values for these two pointer will be -1 because it doesn't have anything. Same as like what is the value of top pointer in empty stack, that is -1. So we are going to follow the same value. Okay, now so here are the data I'm going to insert: 5, 10, 3, 1 and 8. So here the array size is 5. I'm going to insert this 5 data into this queue. Okay, so first I'm going to insert 5. So let me see, for example I can write with a function nq of 5. Okay, so initially the front and rear pointer I'm going to take as f, and for rear I'm going to take r. Okay, see, initially both pointers, see, front and rear always points to -1, which is the list is empty. Okay, so we can consider now we are going to insert a data 5. Okay, so front pointer and rear pointer points to the same position. So just consider it doesn't have data. Okay, so what is the first position of queue is 0. Okay, now I'm going to insert this 5. Okay, so for insertion, what is the condition, what is the limitation I'm going to check is whether the queue is overflow or not. Okay, so what is the condition? If the queue is overflowing, so there is no data, there is no space in the queue, I can't insert new data further. Okay, so first I have to check. So when I'm doing the implementation, I will explain you deeply about the limitation. Okay, what is stack overflow, queue overflow and queue underflow. Now after inserting 5, next I am going to insert 10. After inserting 10, see, front pointer will not move from the first location. Okay, so front pointer will not move after inserting the second data. Okay, so then only a rear pointer will points to the newly entered data. Okay, now r will move to the next place, which is r plus plus. One step it's incremented, and then when I'm trying to insert 3, again r pointer will move to the last position, the last data which entered into queue. Okay, so meanwhile 1 and 8, 1, 8, rear pointer always point to the last data which is entered into queue. Okay, now so I hope you understood how the insertion is working. Okay, so when I'm trying to delete a data from this queue, so what is the limitation is queue underflow. So I have to check whether the queue is empty or not. If the queue is empty, I can't delete any data from the queue. So the condition is, if the queue is empty, the situation will becomes stack underflow. Okay, so I can't delete the data from the queue. So just consider here it's an empty queue. Okay, So if there is no data means I can delete any data from the queue. So then, so in this field data, so this has a full of data. When I'm trying to delete a data from this queue, so after checking whether the queue is empty or not, and then after satisfying the condition, see, my front pointer is points to the first data, because which is the first data entered into this queue, which is 5. As per the first in first out principle, I have to delete the first data from by using this front pointer. Okay, simply what I have to do, just I am going to increment one step to this. Front pointer will move to the next position, then I will delete this data. Okay, so when I am doing the implementation, you will understand clearly how it works. So simply we have to increment the front pointer one step, and we don't need to disturb rear pointer when we are trying to delete the data from the queue. Okay, so that's the whole thing, the basic operation and pointers and the limitation. So I hope you understood the logics very well about the introduction to queue. Okay, so simple thing, when they are in the question they are asking about queue means, what are the things you have to write is, first you have to write the definition, what is queue, and then what are the pointers it has, and then what are the basic operation and its limitation. Okay, that's simple. And in next video we will see about implementation. We have two different types of implementation. First one is using array and second one is using linked list.